Hello everyone, today is May 22nd, 2022. Yeah, it has been a long time. I have created a new video for this one. Today we try to do binary search tree iterator. So let me see the requirement. Implement the BST iterator class that represents an iterator over the in-order traversal of the binary search tree. And there's three functions required. The first one is BST iterator with parameter the tree node to a root. Initialize an object of the BST iterator class. The root of the BST is given as part of the constructor. The pointer should be initialized to a non-existent number smaller than any elements in the BST. Okay, let me double check. So the root of the BST is given as a part of constructor. And the pointer should be initialized to a non-existent number smaller than any elements in the BST. Okay, the boolean function has next return true if there exists a number in the traversal to the right of the pointer, otherwise return false. And third function is next, return the integer moves to the pointer to the right, then return the number at pointer. Okay, looks like we just need three functions to do the in order traversal. And notice that by initializing the pointer to a non-existent smallest number, the first call of the next to the next function will return the smallest element in the BST. You may assume that next calls will always be valid. That is, there will be at least a next number in the in-order traversal when next is called. So example, there's a tree, root is 7 and BST tree, and that's example for the input. They try to initialize that one, and after they call next, that will return 7 as the in order traversal. 3, 7, and 9, 15, 20. Okay, and each next before next function they call that has next to make sure that is the next available. Okay, and constraints. The numbers of the nodes in the tree is a range 1 to 10, 20, 100,000. Okay, and the node value is 0 to 1 million. Yep. I lost. It's a really long course. 100,000 calls will be made to have next and next. Could you implement the next and have next to run to an average big O1 time and use big OH memory, which H is the head of the tree. So things that's required, as my understanding, so I think that's the basement memory requirement is OH, the head of a tree. That seems we need to create a data structure to store the current head of the tree, and that will be quick to the has next and O1. Okay, so all these function is right here. Let me try to think about the first one is about the create. Okay, the create. Okay, so in that tree, look at that tree, and I'm thinking with that tree we need a class. The root of BST is given as a part of the constructor, the pointer should be initialized to a non-existent number smaller than any of the one. Okay, we call that one. We call, okay, that's the next. I'm thinking, so that's basically C++ code. I try to convert to the C language code as well. I'm thinking, so that's the root tree nodes right here, and with the iterator pointer, okay, we could call his next. Okay, okay, next. Next means okay. Okay, we need a handle. I'm thinking, okay, back to here. I'm thinking if there is necessary, we store the nodes next as well for that structure. I'm also thinking, let me think. So that's the one. Oh, oh, it seems we need such structure, and with the input tab, we need a structured motif to store the current states. We don't need the rule. We don't need the next. We need the current. Current. Okay, current. I'm thinking, so for the skin, okay, let me do this. So first one, we will do, if has the next, then we'll call the first. Let me see, he called next first. So anyone he called that one, and when we do that, okay, so we call that, we return that. Okay, it seems we need to store the root. Okay, current current root. And if that one, after that one, we just switch. Okay, we just store the root. It seems we don't need to store anything here. The current root, that's it, right? Let me see. So I'm thinking how we could optimize the memory to, speed up the call. Okay, the next. Okay, that's the thing. So we get right, we need search down every time search down. Okay. I try to Okay, back to the pad I'm using now and try to do this. Let me think. So I'm thinking for the tree. Let me do this. That's 7. Anyone, I make up one. 7, 3, 15, 9, and 20. Okay. On the very beginning, we do this root, and we just return the next. If that has next, I just check if that is root is now or not. After that, I will return this one and going to there and return this one. Return. Okay, return. Then after okay, next time I got the 15, I got the 9, that's no problem. So if that 9 has maybe the 8, that's okay. So we need to search to the end. Oh, we need another marker to mark. I'm thinking if I need that's current root, and that's the maybe the parents. That's the return one. Okay, so every time we mark 1, 2 right here. Okay, and we search down. We know we had got this one returned. So how we handle that? I think we need a way. Okay, it seems for me it's good. I need a create maybe a data structure for the maybe what, let me think. That will be the first in, last out. So we need a stack for this. Okay, I'm going to create a stack and pop in every root. Okay, so that will be, so the stack will be the head of the tree. Now I'm thinking how I tell the head it is. Okay, based on the input, there will be the tree structure. Okay, we don't know the head. We also need a function for the head to check the tree head. Then we, based on the tree head, we could malloc a stack to get that one. Okay, that will be the major data structure in the iterator. After that, there will be the basic operation to get the next, and the pop up, all this stuff. Okay, I think that's what I got to figure out the function. So I don't need multiple pointer for the tree root. I just need the tree pointer of the tree node to start in the stack. That's all. Okay. That will be this one. Let me export. Oh, I changed my mind. I do that later. Okay, I'm going to do this in my favorite console as well. What's the while no binary search tree iterator? Binary search tree iterator dot c and paste. Okay, that's my analysis. I'm going to do the coding next time. See you.